Hey everyone, welcome back to the channel. Today, we're peeling back the layers of a real-world machine learning application, fraud detection. This infographic shows us the journey of data as it gets processed, engineered into features, combined with labels, and ultimately used to train a powerful fraud scoring model. It's a fantastic example of a complete ML pipeline in action, so let's get started. Our story begins with the lifeblood of any financial system, transactions coming in through the payment gateway. Think of every purchase, every transfer, all that data flows into our pipeline. Next, these raw transactions land in the transaction ingestion service. This service is responsible for taking in this continuous stream of data and preparing it for further processing. Often, in real-time systems, the data then flows through a message broker like Kafka. Think of Kafka as a super-efficient highway for data, allowing different parts of the system to communicate and process information asynchronously and reliably. Here, the raw transactions. Now, a crucial part, the fraud scoring service. This is where a pre-trained machine learning model, represented by the model artifact, takes the incoming transactions and assigns them a fraud score. This score indicates the likelihood of the transaction being fraudulent. Importantly, this service also saves its model artifact, the trained brain, for later use. Based on the fraud score, different actions can be taken. The transaction updater service might flag the transaction in a database, while the SMS alerting service could send a notification to the user if a suspicious transaction is detected. Now, let's look at how the model actually learns to identify fraud. We have a data warehouse containing historical data. The feature engineering service plays a vital role here. It takes this raw historical data and transforms it into meaningful features. Think of features as specific characteristics of a transaction that might be indicative of fraud, like the time of day, the location, the amount, the user's past behavior, and so on. The contextual features ingester might pull in additional relevant information from the data warehouse to enrich the features being engineered. Crucially, to teach the model what fraud looks like, we need labels. These tell us whether past transactions were actually fraudulent versus non-fraudulent. This is the ground truth that the model learns from. All the engineered features are stored in a feature store. This is a centralized repository for managing and serving features. It's organized into feature groups, grouping related features, and a labels group for our target variable. The feature store ensures consistency and makes it easy to access features for both training and serving. When it's time to train a new model, the model training service doesn't directly access the individual feature groups. Instead, it uses a feature view. Think of a feature view as a specific selection and combination of features from the feature store that are relevant for training a particular model. The model training service is where the magic happens. It takes the selected features from the feature view and the corresponding labels, fraudulent or not, and uses a machine learning algorithm to train a model artifact. This artifact is the trained model, the brain, that can now predict fraud scores. Once the model is trained and evaluated, the resulting model artifact is stored in a model registry. This is a central repository for managing different versions of your trained models, making it easy to track, deploy, and roll back models as needed. The fraud scoring service then retrieves the latest, or best performing, model artifact from the model registry to perform its real-time scoring. So, there you have it. A detailed look at the training pipeline for a fraud detection system. It's a complex but incredibly powerful process involving data ingestion, feature engineering, labeling, a centralized feature store, model training, and a model registry. This continuous cycle of learning and improvement is what allows these systems to effectively identify and prevent fraudulent activities. What are your thoughts on this pipeline? Let me know in the comments below. If you found this explanation insightful, give it a thumbs up and subscribe for more deep dives into the world of data science and machine learning. Thanks for watching, and I'll see you in the next video.